of proportions and look at means. The testing is no different. The steps are no different. But you guys know there's a little bit of minor changes between means and proportions. So a couple weeks ago, you guys ran out in the hallway and you gathered data, the largest snap streak for Snapchat users. So my claim is that the longest snap streak for all Snapchat users is about 600 snaps. So my claim is that the average longest streak is 600 snaps. And so we want to test this claim with a level of significance of 2%. Okay, so the first thing we're going to do is name this test. This is not proportions, this is means. And so for means, I have a one sample. Okay, because right now we just had one sample of 40 kids. This would be a one sample t-test. Okay, remember sometimes we will do z or sometimes we will do t. We will do z if the population standard deviation is known. Okay, so that's sigma. If sigma is known, we will do t if sigma is unknown. And guys, we don't know sigma. We don't know anything about all Snapchat users. That's what we're trying to predict. I think it's about 600, but we don't know, okay? And so we're going to see if we have enough evidence to prove that. So we're going to do a one sample t-test. If we knew the standard deviation of the population, it'd be a one sample z-test. We do have to identify our population. And remember, we're predicting mu, so you have to have mu equals. So remember, mu is going to be the mean, longest or largest, whatever the lingo is, snap streak for all Snapchat users. Okay, keyword is all. You have got to make sure you're not skipping any steps, leaving out any keywords. Don't get lazy. Okay, all right, now we've got to write our null and our alternative hypothesis. Okay, they're going to have mu now because we're making predictions about the mean. Okay, we're making predictions about the mean, not proportions, not x bar. Now remember, your equality goes here, and I think it's about 600. So this right here is our claim. So at the end, we're either going to reject the claim or we're going to fail to reject the claim. Okay? Now, the alternative would be it doesn't equal 600. And this tells me we're going to do a two-tailed test here in a minute. All right, now let's see. Level of significance we've already discussed. We're going to use 2%. Okay, we're going to use 2%. So what this does is, since it's a two-tailed test, it's going to split that 2% up, and you're going to have 1% of data here, 1% of data here, and that leaves this middle 98%. Okay, these rejection regions would make up your middle 98%. All right, and we're going to look at that here in a little bit because you guys have already calculated that confidence interval for the middle 98, and I'll tell you what that is here in a little bit. All right, now we got to look at our statistics. So what data did we gather as a class? You guys gathered numbers from 40 people. Our sample mean was 549.825. Our sample standard deviation S, that's an S, is 625.7196. Okay, so we have to calculate sigma sub x bar. So we have to calculate what this distribution of samples, what that standard deviation would be. Remember, it's S over square root of n, and you have to show the formula. If you don't show the formula, then you have to show it mathematically. So I've got my standard deviation over square root of 40, and I am going to put that in my calculator. Let's see here. 625.7196 divided by square root of 40. And I get 98.935. So I'm going to estimate just a little bit. All right, from here, we get to check our lovely conditions, okay? We get to check those conditions. We can say that this is a random sample, so a random sample was taken. Now, I don't know why I put an S there. We couldn't have the same person in our sample, so they've sampled without replacement. You don't have to note that they've sampled without replacement. We just need our population to be 400, okay? So our population would be Snapchat users. So there are at least 400 Snapchat users. We could say in the population if you want. I don't think it's necessary. But again, you still have to be specific. There's at least 400 Snapchat users. Then the final one. I don't have to do success fail rule. There is no N, or there is no, sorry, P or Q. But I have to look at that sample size. Because my sample size is 40, it's bigger than 30, then we can say the sample size is large enough we could say that the distribution is nearly normal. Okay, and your wording doesn't have to be exact, but remember, if you start talking about the shape of the distribution, then you've got to use that word nearly or approximately or roughly. Don't say the sample size is large enough that the sample is normal, because remember that we're going to take a bunch of samples. All right, so we don't want to know the sample. We want to know the population. All right, now we can start calculating. Remember, this is a T, so we got to find our T. And it's just like proportions. You're going to take your sample statistics minus your population parameter that we're predicting over the standard deviation. Okay, so we're going to take our 549.825 minus our claim was 600, and we're going to divide that by our standard deviation, 98.935. And then when you put that in your calculator, I get negative 0.507. Negative 0.507. Now, I cannot go look that up on my t-table. It's not there, okay? It doesn't work like Z. So I've got to get my p-value from my calculator, okay? You still need to show your t. All right, so to find our p-value, we're going to use that test in the calculator. So we're going to use the t-test. All right, so just make sure you're writing down everything that you're doing. So I'm going to go over stat, test, and do not write down the buttons you are pressing. All right, so the first thing my calculator asks me is mu sub O, so I'm going to put my 600. Then it asks for the X bar, so that's my 549.825. It asks for S, and if you want to put the little sub X, you can. But that's the 625.7196 that we got from our standard our sample. Then it says N equals, so I'm going to type in 40. And then my last thing, I have to tell my calculator, okay, which tail do I want? So either write two-tailed, which is not a terrible idea, or you could put two-tailed. You could put in my calculator, I could put mu does not equal mu sub O, something like that, okay? And then I'm going to go down to calculate, and you can kind of check your T. Does your T match up? And then our p-value is 0.6149. 0.6149. Now, remember, our alpha is 0.02. If p is lower than alpha, we will reject, but it's not. So we're not going to reject. So remember, those words are fail to reject. So conclusion, if I could spell, this would be great. So conclusion, fail to reject H sub O, since 0.6149 is greater than 0.02. So we're not going to reject it. So if we're not going to reject it, remember that is my claim. Okay? So all I'm going to say is there is not enough evidence to reject the claim, or even better, you could put Miss Admire's claim, that, and this is where I would go look at wording. Okay, so what was my claim that I specified at the very beginning? The longest snap streak for all Snapchat users is about 500 snaps, or 600 snaps. So that the longest snap streak for all Snapchat users is about, or even better, I would put on average 600 snaps. Okay, so we're not rejecting this, which tells me, if you go back up here, it tells me that my p-value, my t, is not in either one of these rejection regions. So my t is somewhere in here in the middle 98%. Well, when we calculated the middle 98%, they go together, you guys. The middle 98%, when you guys calculated it in class, was 309.82 to 789.83. Sorry. 600 is in there. So again, we have enough evidence. According to our confidence interval, 600 lies within the interval. So again, we have enough evidence again to conclude that the longest snap streak for Snapchat users is on average 600 snaps. So by doing the hypothesis testing, by doing the confidence interval, we're getting the same answers, okay? If you guys have any questions at all, feel free to email me.